For section 8.7, we talk about factoring special cases. So far, we've talked about factoring using different methods based on our setup or situation from the very beginning. Here in 8.7, we're going to look for special, unique cases that have a specific formula that will help us factor. First case is factoring with perfect square trinomials. If we look at the formula below, we have a squared plus 2ab plus b squared. And we'd say, all right, well, that just equals a plus b squared. Now, I'm with you. I understand letters are a little bit confusing and misleading. An example of this case would be if we had something that was like x squared plus 8x plus 16. What we need to notice is that my first term is a perfect squared. It's just 1x squared. My last term is also a perfect square. It's positive 16. Therefore, in the end, I know my answer would be in the format of a perfect square binomial, and I would have x, being that that's the square root of the first term, plus the square root of my last term, which is the square root of 16, is just 4. So my answer for that problem would be x plus 4 squared. Now that's a pretty basic case, and one thing to note too is if you just approach this as factoring when a was equal to 1 and you came up with both binomials, you would have gotten the same answer. So you know how to do this without knowing the special pattern. And on a test or a quiz, I don't mind if you do it the old way. However, there's going to be a couple problems with extremely large numbers that it would be beneficial to recognize it as a perfect square trinomial. Our next case we have down here, and that is difference of squares. Formula is a squared minus b squared equals a plus b, a minus b. Once again, I understand that those letters could be a little bit confusing. An example of this property is if I had x squared minus 9. My final answer here is as simple as saying make the two sets of parentheses. The one thing that I need to know is I have a difference of squares. X squared minus 9. It's a difference of two squares. So my parentheses are going to be the square root of the first term in the beginning. Square root of x is just x. One's going to be plus, one's going to be minus. And then my last term is simply going to be the square root of that last term, 9, so 3. And that would be your final answer for this example of difference of squares. Now, take a second and make sure you have this written down. I did this on a separate page so that you would have the formulas and you would have an example of each written down, and then I'm going to go ahead and do a couple more of case 1, and then I'll do a couple more of case 2 later on in this video. So please take a second, make sure you have this written down, pause it if you need to. These formulas are going to be used all day tomorrow, or rather all day Monday in class. Here is another example of case 1. We have 4x squared minus 12x plus 9. Now, just so we're all on the same page, you could perform this factoring by noticing you have a trinomial and the a value is not equal to 1, and you could finish it using the AC method. However, I noticed that this is a special case. And what I mean by that is my first term is something squared. My third term is also something squared. That would be the 9. Now, this is the special case of a perfect squared binomial. So what I'm going to do is get this set up, knowing that I'm going to have a binomial squared. My first number in this binomial is going to be the square root of that first term. So the square root of 4x squared would just be 2x. My next number would be the square root of 9. That would just be 3. Now, the sign in the middle is always going to match the sign in our binomial. In the first example, you saw a plus there because the middle sign was plus. However, I have a minus sign right above this that tells me this will also be minus. And next example, and as I'm writing this out, I'm going to talk about why this formula is beneficial. So as I do this, we have 100r squared minus 220r plus 121. Now, if you try to do the AC method for this problem, you'd be multiplying 100 times 121, trying to come up with that number trying to come up with two numbers that multiply to get that and combine to give you negative 220. Or, at the very beginning, we could have noticed that my first term is something squared. In this case, it's 10r being squared. My third term is also something squared. In this case, it's 11 squared. Now, the sign that goes in the middle is a minus sign, and I also have to make sure I square that binomial. So I could have been done by knowing and recognizing that special case in a step and doing a method using the special cases, using the formula from the first slide, and I could have been done right away. Here are two more examples of my second case, and that's a difference of squares. As you see in problem number 3, I have x squared minus 81. X is squared, the 81 is 9 being squared, and I have the difference. Subtraction only will work for this, so I have x squared minus 81. Now, if I do play around with my formula a little bit, and I think of this term as being my a squared value, and I picture this term being my b squared value, I notice I have a squared is equal to x squared, and I also have b squared is equal to 81. Now, the formula tells me I need to write this as a plus b times a minus b. So in this situation, what I'll have is going to be a is equal to x, and b is equal to 9. So I'm going to have x plus 9 and x minus 9. In my next problem, I'm going to approach it the same way. I'm going to think of this entire piece as being my a squared. So a squared is equal to 4x squared. Now if I just focus on what you see in red for problem number 4, I can instantly see that my a value, if I take the square root of both sides, will be 2x. Moving to my b squared value, it's 25. So I have b squared equals 25. Now, most of us should know, but the square root of 25 is 5. So now as I go to do my setup, if I kind of let my eyes adjust to this formula above, a plus b, a minus b, what I'm going to see is a plus b times a minus b. That would be your final answer. So recognizing the situation not only will tell you what method to use, but it's also going to tell you if you need to do any kind of special case formula. One other thing to keep in mind, and I will ask you guys about this on Monday in class, is the first step to factoring any problem is to take out the greatest common factor. Enjoy your weekend or enjoy the rest of your Sunday night, and we will see you soon.